Hello everyone, welcome back to again in my channel. My name is Prashanja, as you know that, okay, and let's take a next question. So you know the question also. So my question is that why all the fundamental data types are immutable? And you know the meaning of immutable also, guys. You know the meaning, okay? You know the meaning of immutable. Okay, what's the message? Nothing is that. Okay. So why all the fundamental data types are immutable? Fundamental means you have predefined data type. We are talking about the predefined data type, and this is very, very important to all of you, as you know that. So, like integer, float, string, boolean, and complex. These all five fundamental data types means your predefined data types we have, but they are not. That means they are immutable. What is the meaning of immutable? So, if I'm going to explain in a very simple way, verbally, so it is not going to be understandable. Let's take an example. As you know that I'm taking an example and I'm explaining you the answer. So this is very important to all of you. Okay, let's take that. So what I'll do exactly? Yeah. Let's take example like maths. Suppose in the math subject you got a marks 50, okay, and same in the physics subjects you got a marks in 60. Okay, that's really cool. Maths you have a 50, in physics you have a 60. That's really cool, I will say that. Yeah, okay. Now here, what will happen exactly whenever, as you know that your execution will start from this first line, okay? So obviously it will create a memory and it will store the value. Your interpreter will create a memory and store the value like 50. Okay. So before storing and before creating a memory, your interpreter always, first of all, the job of your interpreter to check is this kind of value is already exist in any existing memory. Any existing memory is having the same value. If it is having, so it will assign the same memory address to that variable. But here right now you can check, like I'll take the example in our college life and in school, our academic, what will happen, suppose we got the assignment from our instructor, from our teacher, and any practical assignment. And first of all, what we do exactly, we try to search that assignment practically in our circle, in our surrounded area. We have a lot of friends, and we always try to first of all search, okay, this assignment, or suppose this particular topic is having some predefined notes, and already any student is having that notes, physical or digital, soft copy or physical copy of that notes. So we always try to ask, okay, give me that copy, or I'll take a Xerox, whatever the things, because we don't want to spend again very much time to just create a same notes again and again if it is already exist. Similarly, when the value is already exist in memory, we don't want, and even interpreter doesn't want that to create a same, no, create a separate memory for storing or holding the same value. So it always check, like in your first variable you can check mass equal to 50. So it is 50. It will create a separate memory because there is no memory. So it will create a separate memory, store the value 50. But in next paper you got, suppose in physics also you got 50. So same time, in this time, after creating a first memory, when your interpreter will reach to the next line, and when your interpreter will get, okay, we have to store the value 50. So again it will check, okay, is there any existing memory which already having the same value? Yes, there is an existing memory, and this math variable representing that memory, and this 50 is stored in that memory. Okay, so physics equal to 50 means your interpreter will not going to create a new memory. Your interpreter will assign the address of same memory to this variable, because at then variable, that value variable will be changed. Okay, it is possible to change the value of variable, and all the value we are creating and we are storing here, that is for temporary purpose. It is not going to store permanently. It is going to store for the temporary purpose. So same value, if we required, if we want that two variable representing the same value, why it should create a separate memory? So it is going to, that means why it creates a different memory should represent, it should take the value from the same memory. So that is the same thing. How we can check, as you know, that means we have to check the address if we have to verify it that both the variable is having the same memory or not. So using the id function, just put a first variable maths and just use the same print id function. I'm just going to use the physics. Okay, this is also very important. This two variable we have taken and we have just represented the maths and physics. So we will check the address. id function used to return the address. If both the variable having the same address, if both the variable representing the same address, means we can say that your interpreter does the same job which I have explained right now. It will not create a separate memory for the same value. Okay, and the job of interpreter is always First of all, whenever you create a variable, whenever you create an object, it will always check that this value is already existing in any memory or not. If it is already exist, it should not create the same. We can say that a memory, a different memory for holding the same type of value. So it will assign the same memory address to that value. Okay. So here you can see, just run this. I know that I'm taking too much time, but sorry for that. Now just pause this video and check the address very carefully that both the address is same or not. Okay. Now, suppose I'm going to take the next variable. Okay. Chemistry. And here again, have taken 50, same value. Again, your interpreter will check, okay, this value is 50. It will check, is there any memory? Yeah, there is already we have a one memory. That memory is holding the same value. So same address will be written and assigned to this variable or this object, we can say that. So print again the id function, and we will use the chemistry. Okay, that's really cool. And just clear this. Again, I'm going to run it. Wow, that's good. So here again, you can pause the video and you can check it. Okay, you can check the address. Yeah, address is same. Okay, almost same. But suppose right now I'm going to take a different, because I'm just taking the same value, so it's not good. Let's take a 60. I've just taken the 60. This time again, your interpreter will check. Okay, this variable or this value is having already any memory is having the same value. No, because if you check the three here variable is having the same value, but there is no other variable is holding this 60, so it's a new value. It will create a separate memory for this storing this new value, and obviously if it is a separate memory, then it is a separate address. It will show you the separate address. Okay, so let's take id, and here it will show you Hindi. So I'm just going to check, run. uh, yeah. So now you can again pause this video and you can check. First three, address is same. The last address is different. Okay, that's really cool and good. That's really cool and good. Okay. So why last address is different? Because the value is different, as you can see. Okay. So I hope you have understood this question answer, like why all the fundamental data types are immutable. And this is helpful and understandable for all of you guys. Thank you very much. We'll see you in the next not a next lecture, it's a next question, next interview question. Okay, till that time, enjoy your life. Thank you.